Hello, thank you for joining. My name is Scott Donahue. My colleague Setu and I are Microsoft Cloud Solution Architects specializing on machine learning and AI on Azure. And today we want to introduce you to a new project designed to help bootstrap and accelerate new ML projects in Azure to a quick, reliable, and repeatable MLOps workflow. Unfortunately, my colleague Setu is ill today, so I will be presenting. Please put any questions you have into the chat. I will be pausing for questions at various points in the presentation. So first, I'm going to quickly cover some fundamentals of MLOps and the challenges. Now, this audience is likely already familiar with MLOps at this level, so I'll keep this brief, but I wanted to set the stage for the motivation and the goals of this particular MLOps project and how we set out to address those challenges. So the fundamentals and the value proposition. Why did we do this? So MLOps is DevOps for machine learning. It enables data scientists and IT teams to work together and increase the pace of model development through monitoring, validation, and governance of the machine learning models. The business cannot get optimal value from a machine learning model if it's languishing on the laptop of a data scientist, or what it means to use that model in production isn't well understood, or it's hard to implement, or the skills needed to do it are spread across disparate organizations that don't often collaborate. So for MLOps, we cannot just be stalled at developing a good model. We need ways to package it consistently, validate that it delivers value in production, can be consumed by the business either by applications or real-time dashboards, and is monitored to understand when it needs to be updated by going back to training. So what are the challenges that make this difficult? First, we have a lot of different roles and skills that are needed for effective MLOps. You have data scientists who focus on the model, ML engineers who may focus on deployment, software developers, and infrastructure and security teams. And they don't necessarily speak each other's language or know each other's skills. As well, there are a lot of different tools across all the different elements of MLOps. So the data scientists may be using RStudio notebooks, and there are machine learning services for the ML engineers, code repositories, either Azure DevOps or GitHub, and different ways of doing CI/CD, both Azure DevOps and GitHub Actions. And many, many different ways to interpret what it means to deploy in production. A lot of those involving Kubernetes or batch deployment. So this needs a lot of different skill sets to do successfully. As well, you have artifacts and versioning. So we don't just have source code versioning now, unlike in DevOps. We also have data and schema and snapshot versioning. We also version our models so that we can track the history of those models. So there can also be a disconnect, and maybe the data scientists don't have access to production level data. So they're developing their models on development or training data, and we don't know that necessarily that the model that they've developed is going to perform the same way in production when it sees new data. So these production models need monitoring and retraining. So the challenges come down to a separation of people, different processes, and different platforms. So let's talk about the approach that we took with this project that I'm talking about. So we call this MLOps V2. It's an update to the MLOps patterns and practices that we had previously recommended at Microsoft, and we wanted to bring this up to date with all of the tools available, all the different things that our customers have been asking for, as well as integrating all of the best practices that we've seen from our field experience. So to accomplish this, we started off building this project with 5 philosophies. One is simplicity. We want to keep a segregation of duties. Second is speed. In our experience, it's taken so long for customers to successfully go from a model on a local machine to enterprise production MLOps. It can take weeks and months. And we built a project to help bootstrap each data science project in a little under an hour. Agility, we wanted to be able to enable quick prototyping and operationalization of different ML use cases. Repeatability, we want to standardize and make time-efficient processes to allow the MLOps to operate at scale. And lastly, modularity. So we wanted to have a pattern that modularized the features of the workflow into distinct components. So this enables things like different choices of, say, a feature store or responsible AI checks. So the solution accelerator is that I'm talking about is a GitHub repo or a collection of GitHub repos that is organized into multiple repositories of templates that are used collectively to bootstrap a new data science project. So given the needs of your particular project or your data science scenario, the CI/CD pipeline platform that you use, and IT infrastructure, this parent repo MLOps v2 generates a new project with an end-to-end MLOps lifecycle with each concern clearly separated by role. So currently, the MLOps v2 accelerator supports 3 data science scenarios: classical ML on tabular data, computer vision classification, and NLP summarization. And more scenario templates and variants of those templates are under development right now. The design of the architecture is based on the idea of separation into an inner loop, the typical iterative data science development lifecycle, and an outer loop where staging, test, production deployment, and monitoring take place. Connecting these loops are Azure Machine Learning model registries using MLflow for experiment and model tracking. Other models that may be included in the architecture are responsible modules, modules that may be included are responsible AI checks, feature stores, and data drift monitoring. The accelerator structure itself uses the parent template repositories that I described on the last slide and performs a sparse checkout on the specific features that you want for your project. So next, I'll walk through the overall architectural patterns in some detail, starting with the baseline classical ML architecture, but I'll pause here to see if there are any questions so far. Don't see any in the chat. Okay, so we'll continue. So this is the baseline architecture based on an overall workflow for a classical ML scenario. And it's the model or the base for all other of the ML architectural patterns that we have. So the CV and NLP are modifications to this. So let me go through each of these in a little detail. At the end of the presentation is a link to the Azure Architecture Center where we'll dive into these in further detail. The number one is on the left is the data estate. So this just represents the overall data state of your organization and potential data sources and targets for a data science project. Data engineers would typically be the primary owners of this element in the MLOps v2 lifecycle. The Azure data platforms in this diagram aren't exhaustive and they're not prescriptive. We're just representing what some of your options are. In some cases, we do represent what are recommended best practices by a green check mark here. So the second element here is administration and setup on the lower left. This is really the first step in the accelerator deployment. It consists of all the tasks that are related to creation and management of the resources and roles that are associated with that project. So this can mean creation of project source code repositories, creation of machine learning workspaces using Bicep, ARM, or Terraform, creation of data sets and compute resources that are used for the model development and deployment, and definition of the project team users, their roles, and what resources they have access to and do not have access to. Creation of any CI/CD pipelines, and creation of monitors. So the primary persona associated with this phase and this section of the accelerator would generally be the infrastructure team, but it's also going to be informed by data engineers, ML engineers, and data scientists as well. So the initial main loop, number 3 at the top, is the model development or inner loop. And this consists of the traditional iterative data science workflow. So it's the data scientists that have access to a dedicated workspace and training data, and going through the typical life cycle of ingesting data, EDA, feature engineering, experimentation, modeling and training, and evaluating those models. And this is typically going to be data scientists and ML engineers in this phase of the accelerator workflow. So for number 4, this is the machine learning registries. Azure Machine Learning has a registry that allows you to register each model. When the data scientists have a model that is a candidate for production, it's registered into Azure Machine Learning registries and can trigger a CI/CD pipeline, CI/CD pipeline into the outer loop, consisting of staging, test, and production, using either GitHub or Azure DevOps. And this could be an automatic deployment, or it could be some sort of approval method with a human in the loop. So number 5 is the model deployment or outer loop. This consists of pre-production, staging, and testing of the model, production deployment and monitoring of the model and the data and the infrastructure. CD pipelines manage the promotion of this model through all of these different phases here, using criteria that are appropriate to your organization, and each use case is satisfied. So this will primarily be the domain of machine learning engineers. So staging and test, this can vary with customer practices, but it typically includes operations such as retraining and testing of the model candidate on production data, test deployments for an endpoint performance, data quality checks, unit testing, and so forth. And again, this can take place in a separate workspace that is secure and independent from the model development workspace. So for production deployment, number 7, after this model passes staging and test, it can be promoted to production by using human in the loop gated approval. Model deployment options include a managed batch endpoint for batch scenarios, or for online near real-time scenarios, either a managed online endpoint or Kubernetes deployment using Azure Arc. For monitoring in staging, test, and production, this makes it possible for you to collect metrics in Azure and act on changes in the performance of the model, the data, and the infrastructure. Model and data monitoring can include checking for model and data drift, model performance on new data, and any responsible AI issues. Infrastructure monitoring is there to watch for any things like slow endpoint response or inadequate compute capacity or network problems. Now, based on the monitoring and triggers and notifications occurring, data and model monitoring can notify a user or go back to automated retraining if that is part of the workflow that you desire. Or it can have a human in the loop and go all the way back to model development to investigate what the problems are. For infrastructure monitoring, we're monitoring for events and actions on the health of the infrastructure, and any notifications or alerts on that side would go back to the infrastructure team to make any needed modifications to administration and setup. So the next 2 slides are for computer vision and NLP. And for the most part, These architectures are pretty much the same. Now, the inner loop and administration are a little bit different because for computer vision and NLP, you may have a labeling and annotation task that is necessary, and the inner loop model development cycle is a little bit different. But the biggest call out on the different NLP and vision architectures is that we typically would not see any kind of automated retraining in production. When a new image comes in and is processed by a computer vision model, if it performs poorly on that image, we don't want to automatically retrain. We have to send this back to the inner loop for investigation. We have to have a human in the loop there to identify why it performed poorly, what are the characteristics of that image, and maybe include it in the data set and relabel and retrain. And the NLP architecture is very similar to this. It has some of the same caveats, that the inner loop is a bit different than we would normally see in the traditional classical ML inner loop. And as well, we do not have any kind of automated retraining. This would always be a human in the loop scenario here. So here is a more detailed look at the solution accelerator repository architecture and the options you have for each deployment template. So the deployment process, starting with the MLOps parent repo, allows you to select the data science scenario from the project template appropriate to your project, either classical ML, computer vision, or NLP, as well as the infrastructure deployment your IT team uses. Terraform, ARM, or Bicep are your options. The MLOps templates repo on the left allows for the selection of how Azure ML interaction will take place using the Python SDK or the Azure ML CLI. The CLI can be used to support non-Python workloads such as R. So the final result is a customer project template on the right that organizes all of the elements of the end-to-end workflow into the different roles, data science source code, any local data, MLOps CI/CD pipelines, and infrastructure definitions. And I'll go into each of these different repositories in a little more detail in the next slide, but I wanted to see if there are any questions. And one thing I want to call out here is if you look on the upper right, there are other technical patterns that we are planned to build out here. Right now, it is exclusively Azure ML, but we will have support for Azure ML, Azure Databricks, Synapse, and Edge use cases. Let me see if there are any questions. From Melissa, would you please go back to the previous roles and tasks slide and expand a little on the people involved? How does this work interact with IT as a broader organization? That's a good question. And rather than go back to the slide, I think I will move forward to how the repo is organized and how the infrastructure repo is handled. But we can come back to this question after the presentation as well. So what are the different templates? Creating a project with the Accelerator bootstraps an Azure Machine Learning Workspace, an example data science scenario with source code and data, and pipelines for deploying infrastructure, model training, and registration, and either batch or near real-time endpoint deployment. So the repos are designed to provide a baseline and examples that can quickly get you to about 80% of the way to your production project, leaving you the ability to customize the remaining 20% with your source code and data, as well as modifying or adding new repo templates for your different project types. So let's talk a little bit about the each template folder. The infrastructure folder contains all of the infrastructure templates for each resource type needed for either Terraform or Bicep. And this is managed by your infrastructure team. So your IT team would typically say we use Terraform or we use Bicep to deploy these resources in Azure, and we manage them using these tools. They would have access to this infrastructure and take requests, and working with the ML engineers and data scientists on what's needed for that deployment. But it's separate from everything else so that we can separate out ownership of these definitions for the IT team. The data science folder contains all the source code in the model development workflow, divided into modules as needed. And these are used to build a componentized pipeline in Azure ML. So all of these different components can be worked on independently. Environments are defined here. Things like the training prerequisite packages and any Docker images are also defined here. Logging of experiments and model tracking is done throughout using MLflow. So where possible, we have used open source approaches to implementing these pipelines. The MLOps folder contains the automation and production definitions, including CI/CD pipelines for either Azure DevOps or GitHub Actions, definitions of retraining pipelines that might occur in test or staging in case you have a scenario where the modeling pipeline doesn't even see production data until it gets into that outer loop, and any deployment pipelines as well. The MLOps template repo from which the project repo is generated contains all templates for end-to-end lifecycle management, and it can be modified or added to according to your organizational needs, such as adding new CI/CD tooling or new pipeline stages. So that's a quick summary of this Azure MLOps Solution Accelerator. The goals are, we really wanted to be able to make this simple to reduce the time to value for your MLOps deployments from weeks or months to days or even hours to get that initial end-to-end workflow stood up. We wanted to be able to standardize across the use cases so that we can provide a template for different types of scenarios and simplify the lifecycle with the segregation of duties. So here are some resources I would refer you to get started. We will share these slides so you'll have the links after. The first is the MLOps v2 parent repository. This is where you would get started. The Azure Architecture Center has a document that dives into the various details of the architectures that I described and showed. And 2 days ago, we published a blog about this project on the ODSC, Open Data Science website. So you can go there to read for more information. And now I'll take a look at the question.